Hello everyone, welcome to another video on equations from our topic of equations. Now, today we're going to be talking about formulas and relationships. And this is a pretty big topic that we've been building up to. This is an application of the equations we've been looking at solving up until now. And this is a pretty universal topic, especially in fields of science and maths, and these formulas occur all around us. They occur in all of the scientific in a bunch of scientific relationships and things like that. So it's really important that we introduce it here because the equations we've been solving are the building blocks to a lot of these formulas. So let's actually take a second just to define what a formula is. So a formula is a type of equation. So a formula is an equation that contains two or more pronumerals. Contains two or more pronumerals. So if you remember, we've talked about this before in algebra and even equations. A pronumeral is just a letter that represents some type of number. So here, let's look at an example of a formula. And this is a real world example of a formula. Now, I'm going to write it here. Five plus 32. Okay, so this formula here is actually the formula for converting temperatures from degrees Celsius, which we use in Australia, where I'm from, and degrees Fahrenheit, which is used in the US. So in this formula, we can make a couple of observations. Now, first of all, we have two pronumerals here. So this kind of satisfies our definition for what a formula is. And what's important to note is that one of these things is what we call the subject of our formula. And the subject of our formula is just the pronumeral on its own on one side. So this thing here is the subject of our formula, of our equation. So what we have here is now we can actually we can find relationships between two different pronumerals. So here we're looking at relationships between two different temperatures. I have here and here. I have a relationship between two different temperatures. All right, temps for short. So what this tells us is we can find, for example, the temperature in Fahrenheit for any different value of the temperature in degrees Celsius. So my degrees in Fahrenheit, when actually solving this formula, are going to change for different values of temperature in Celsius. So let's try one example here, and we're going to find F. So find the degrees in Fahrenheit when my degrees Celsius, C, equals 5 degrees. So this here is an exercise in substitution. So substituting, if you remember, we've talked about this before, is the idea of replacing a letter here, with a number value that we've assigned to it. So here we're trying to find F when C equals 5 degrees. So we're trying to find the degrees Fahrenheit when we have a temperature of 5 degrees Celsius. So if you remember in our previous videos, we looked at this idea of substitution. So we're going to put this 5 in place of the C. We're going to substitute C with the value of 5. So let's have a go at that. Now, I'm going to write out my formula again. So my F equals 9. And instead of the C up the top, I'm going to put 5. I'm substituting in a temperature of 5. And that gets divided by 5. And we add 32 to that. So plus 32. Now when we get here, 9 times 5 gives me 45 divided by 5 plus 32. And doing this division over here, 45 divided by 5, 5 goes into 45 9 times. And we're adding that to 32. And when we add those two together, we get 41. So my F, we've just found that when my degrees Celsius is 5, that same temperature is represented as 41 if I was looking at degrees Fahrenheit. So for example, when I'm in Australia, right? So if I go to America and say to someone that it's 5 degrees outside, because I'm used to me, if something's pretty cold, I think of it as, okay, well, 5 degrees. It doesn't get usually below 0 in Australia where I'm from. So I'll say, oh yeah, it's 5 degrees here. But to an American, if I went over and said, oh, it's 5 degrees outside, they're going to tell me, well, no, it's not actually, because 5 degrees to them means something very different to me. And what relates these two is the formula that we wrote up here. So the Fahrenheit is actually always going to be a higher number, as we saw here, 41, as opposed to 5. So the temperatures are going to be different, whether I'm looking from the perspective of degrees Celsius or degrees Fahrenheit. And substituting these values into the formula allows us to find one temperature when given the other. Now, this first part wasn't too bad because we weren't actually solving the equation in the way we're used to, were we? All we did was we just put in a value for the C. We just substituted this. Now let's try a trickier version of this question. So I'm going to say, from this same formula, find C, so find the degrees Celsius, when my degrees Fahrenheit equals 10. Okay. Now, here, instead of substituting something in for my C, I'm substituting it in for my F here. Now, let's have a look at how that would look and how that changes based on how that differs, for example, for the C in the last example. So here, instead, I'm going to put 10 equals 9C on 5 plus 32. Okay, cool. So I have written out my formula, substituting in 10 for F. So instead of the F I had before here, I have put in a 10. And now, well, this kind of looks like an equation we can solve systematically. It's got a bracket in it. Oh, sorry, it's got a fraction in it, which we've dealt with in previous videos. And we can actually very easily now work through this to find what C would be, my degrees Celsius is, if I'm given a degrees in Fahrenheit of 10. So considering this right-hand side, that's got my C, that's what I want to find. I can see that 9 was multiplied by the C. We divided that by 5 and we added 32 to that. So once again, adding 32 was the last thing we did. So we can find what 9c over 5 is before 32 was added. And if you remember, we do that by doing the opposite here, because this will tell us, kind of working in the past, right? This will tell us what 9c over 5 was before we added 32. So 32 more than 9c over 5 equals 10. Therefore, 9c will be 32 less than 10. So let me just make this a little bit nicer. 10 minus 32 gives me minus 22. That equals 9c over 5. Cool, okay. We are now ready for our next step here. So I can work with this fraction in this exact same way that we've done before. I can say, well, the last thing that was done to this was dividing by 5. The last thing that was done to c, or 9c, is dividing by 5. So if dividing a number by 5 gives me negative 22, that number is going to be, that number 9c is going to be 5 lots of negative 22. So minus 22 times 5. Cool. Now I'm going to pop that in my calculator because I'm not bothered doing it in my head. And that gives me negative 110 equals 9c. Cool. Okay, we are almost there. We now want to find what c is. So 9 multiplies by c to give me negative 110. So, sorry, just to get us into good habits of showing our working, I'm going to just write this here, because when we work through these things, we want to show our working. Now, I can do what to both sides? What do we think? We're multiplying here, so I can divide both sides by 9 to get me to c. So dividing by 9, dividing by 9. That's going to get rid of my 9 here, and that's going to leave me with my final answer for my degrees Celsius. Now, this isn't a nice number, so I'm just going to round it off to one decimal place. This gives me negative 12.2 degrees Celsius. So what I'm getting at here is that these values of C or F and any values in different formulas are going to change depending on the numbers we're substituting in. But once we know these numbers, we can really easily end up solving the equations. Even when they look a little bit tougher like they did here, we can still apply what we've been doing up until now. In this question, we applied solving equations systematically. We applied solving equations when fractions are involved, and we can do this for all sorts of questions. But when approaching a formula or relationship question, the steps we want to do is we want to first substitute the value we're given in the question. So for example, here, when we wanted to find f, we want to first substitute our given value here. So we're told that c equals 5. So we can pop 5. We can put 5 just in the place of c. We want to substitute c with 5, as we did here. And in later questions, we can do the same if we're given a different piece of information. So here we're given a different piece of information, that f equaled to 10. So we substituted the 10 in place of f. So in doing these, all we have to do is substitute first and then do the arithmetic like we maybe did up here, or we may be required to actually solve the equation systematically, which we already know how to do. Thanks so much for watching, guys. I'll see you next time.